Welcome all for the presentation Polkadot for Beginners. Today we want to look into basic knowledge about how everything works and the future of it. I'm Torsten Schenk from the Polkadot Ambassador Program, and approach me when you have interest in technical informatics, or I'm also a CTO in a startup in Berlin, which is currently not related to Web3 and blockchain, but maybe in the future. Today we want to talk about the 3 generations of blockchain and the development cycle and the future, and also how everything works for Polkadot when it comes to Web3. And we have a look at the timeline. We see that blockchain started very, very early, already in the 90s. So with Stuart Haber, he already released a scientific paper where he made an approach to chain blocks of data together cryptically. In 2004, basically one of the last milestones was reached in the sense of how to release tokens for cryptocurrency and also how to find consents in a decentralized network, the proof of work in 2004. Short after that, basically the technology was ready to release, and in 2009, Bitcoin went online, was a full success as we know today. That's basically called Generation 1 blockchain, which doesn't have much more than just transactions and a very simplified user interface, but still enough for success. Then quickly, within steps of 5 years, we came to Generation 2, Ethereum with smart contracts and a lot more usability and built-in intelligence. And then already in 2020, Polkadot came up, which focused mainly on very good user experience because it's very scalable and it has interoperability built in on the lowest level. So it's basically made for scaling. When we come to how is a blockchain run, who is running the blockchain, who provides the computational power, we are in the world of the validators, often also called miners. Those validators have very different requirements, and we check what the 3 different generations have said. For example, in Bitcoin, basically currently we have 15,000 validators around the world, where we can say that you need a high-end PC with very specialized graphic cards. This has you have a huge investment in hardware. When we check Ethereum, there we have 821,000 validators currently running, and you need a safety deposit. So the PC is cheaper, but the principle is a bit different. In Polkadot currently we have very few validators, 297. But the deposit is much higher. So why is there a deposit and why does Bitcoin need a high-end PC? The main difference is that the principle to finalize the next block and broadcast it to the other nodes is basically that Bitcoin runs on proof of work. That means you need high computational power to solve the requirements to finalize the block, and then Ethereum, which recently changed to proof of stake, and Polkadot, it's very easy to validate, but you have to make sure that you do everything right, because when you misbehave, you can be charged for it. That's called slashing. So when a validator in Ethereum or Polkadot does a mistake, then the safety deposit can be slashed. And we see in Ethereum that we have here 32 Ethereum as a deposit, it's around $50,000. When we come to Polkadot, we see 2.2 million dots, that's around $8.8 million, which is required to be a full node there. So we see basically that transactions are very secured, so long it stays in range of the deposit. But when you send more data than the safety deposit is, basically then it's a bit, let's say, out of the boundaries of security. So basically on Polkadot you can send basically safely, I would say $8 million, because the validator can be accountable for it. Basically all the validators run open source software, everyone can download, so everyone could become a validator. For example, in the sense of Polkadot and Ethereum, that's often a shared security. So the validators say, okay, who else want to give me his Ethereum, his dots, to help me secure? So I give 500,000, who else gives the rest? So that's often type of nominated and profit is shared. Proof of stake is basically based on security deposit to keep them on the right track. So we saw, okay, we have validators running the blockchain, and the validators have, of course, to communicate with each other so that they build together a big network. So here we can see typical networks. On the left side, centralized. On the right side, distributed network, and something in between, which is more or less the current web, I would say, where we can see the main difference is that the validators here as dots, and the lines basically as communication channels. Shows very clear that the more centralized we become, the more nodes supersede other nodes, so control basically the communication. When we're in a fully decentralized distributed network, on the right side, we can see that there's a lot of ways the communication can pass through the network. And why do we prefer for blockchain distributed networks? The reason is mainly that we want to be very resilient against outages and disturbances in the network. Here we come to network outages. So centralized, we see the main server goes offline, everything is broken. In the middle, decentralized, okay, some nodes go offline, some communication is disturbed, but we can also see that parts of the network can't communicate with each other, so it's pretty bad. And in the distributed network, we see that basically only the nodes go offline that are broken. So the communication can flow freely, which is also very important because when new blocks are finalized, they have to be broadcasted to all the nodes in the network. So everyone has the same history up to the recent block. So it can't happen for a blockchain basically, or should not happen to have a broken communication between the links. So that's our theory. How does it look in the real world? So in the real world, for example, here are the Polkadot validators where we see how they're distributed around the world and how they become activated when a new block is broadcasted around the world. So block time here, for example, is 6 seconds currently, and we see that already here 17 million blocks have been finalized and are in the history. So that was a hardware part, how blockchain is set up around the world in physical computers and internet and connection. So what we found out as a team is that the question of what is a blockchain is very controversial. There are a lot of terms you can see on YouTube. When you Google it, there's a lot of synonyms like Web3, disruptive technology. So it's like very a bit unsharp to say, what is it really? How does it compare? The old internet, the Web3 is coming. So then you hear like, you own your data, that's in Web2 not possible, and so on. So there's, let's say, and then how can we figure out what it really is? How can we explain it easy? And my approach I want to show today is we directly compare Web2, how it's structured, from the user perspective with Web3 to see what is exactly the difference and then compare nochmal the difference to make it very, very clear where it comes from and where it goes to. So for example, here we see Web2, the internet as we all know it, which we use for over 30 years now, where we can say basically there are 3 layers. There's this application layer, the user interface, the web page, the app on the mobile phone, that all often is connected to databases, where our user data is stored, where all the data is shared and where we can query data, put data. Standard is that big companies control those databases. For example, when you think about Facebook, all your data is in databases. Your profile of Google is in a database. Normal databases are owned by private companies. And when it comes to very big data that doesn't fit into databases, then there is an extra file storage external to put huge video data and so on. So we say, okay, now Web3, what is blockchain going to change? Which part is changed? So the part basically blockchain replaces is the database part. That's why also the slogan is there, you own your data. Because when it's a blockchain, you have the keys, it's your data, you can do with the data what you want. In a database that belongs to another company, you don't have that choice, so you can't access the data, you can't correct the data. On the other side, The app layer, as we see here, for example, here's a type of Web3 idea where the database is replaced by blockchains. For example, here from left to right, we have your Polkadot, Fala with a computational cloud, Moonbeam, Polkadex as an exchange, or the Asta, which also connects several more projects. That is basically then the database. On the front end, the applications is just called decentralized applications because they have this backbone decentralized blockchains. For example, the products here or the applications here is from left to right. It's a Nova wallet, then Polkadot.js, a browser extension, then Singular and Coda are NFT and digital asset marketplaces. And we also have the staking pools and open governance there as applications to the user. On the lower side, of course, there will be also lots of data. Where are they stored? That goes not into a private server again. It's again a decentralized cloud service, often called also IPFS. Maybe you heard already that term. And that's basically called interplanetary file system. So you see it's very, very similar. And just the middle level is the difference. So let's compare database with blockchain because that's, let's say, most of the usage you will have with a blockchain later. So here we tried to make a comparison between database and blockchain, where on the left side we have the database. Generally, entries in the database are overwritten and new data comes in. Basically, in a big database, you have to have all the user of Facebook, you have always all the data in one central place. Often the history is not tracked and unknown, so changes just override and we don't know what happened before. Often there's of course an admin that can do with the database whatever he wants, also delete it or change the data or extract data. Generally we can say it's completely hidden from its users, so we don't know what is tracked. On the other side, when we look how blockchain behaves in that case, basically in every block the changes are included. It says positive transactions and negative transactions, so plus or minus. We only have the interacting users in the blocks. The history is immutable and is fully tracked. So everyone can go back and check what happened in the past. It's public viewable in blockchain explorers, also it's completely transparent. And maybe one of the top points for blockchain is that it's completely decentralized and there's no party required. So there's no man in the middle that can interfere with your data. Nobody can change it, nobody can stop it, nothing. That's the main point. When we go through these blocks from top to bottom, we see on the left side that's basically always in the box what is there. And on the right side we see sozusagen that only the change, black markings means removed and white markings means added. So blockchain is differences and database is basically all the data all the time. So we saw only the changes are going into the data, going into the blockchain. Only the changes are going into the blockchain. So when we look at the blockchain in general, we have several blocks connected, called chain together. And when new transactions come in, one of the validators will create a new block, broadcast it and say, okay, that goes into the history and also becomes read-only and immutable when it's validated. So now the last question is still open is, what does this chain mean? Also how are the blocks chained together in a sense of, cannot someone replace a block in the middle? Can I not just exchange a block 102 for another where I have better stats or something? So that's part of the technology to make it extremely hard to change and upgrade. That's at the very base is always when a block is created, of all the stuff that's in the block, we create one hash that verifies that everything in the block has been never changed. And that is included in the new block, and again, calculated into a new hash. So that means when I go back from a higher block to a lower and search the whole history, basically I can always re-verify that the block has basically all the data it should have, because the hash is basically unique. So that means it makes it completely immutable in the past, which of course also then leads to, let's say, difficulties in upgrading a blockchain because it's immutable. How can I upgrade that easily? This then interferes with that. So yeah, we have seen the hardware, we have seen the software side, what's in the blockchain, how it's chained together, how blocks are created, how are they validated and everything. Now stays basically eigentlich, how do I interact with the blockchain as a user? So what's my user interface? How how do I make sure that I own something digitally? And a blockchain is, the clear definition is, you need a private key. That is a definition of the ownership. From this private key, you can derive public keys, which can be used to receive assets, so people can send you assets, and you can also, of course, send your assets to someone else who has a public key. Generally said, and with that I address also because it's an event for beginners, that private key must stay secret. It's very, very important. Sharing it basically gives away all the rights on your assets. You will have no control. You can't take it back. Granting rights means forever. Transactions are, of course, signed with a private key, so to say, yes, I have the rights to send it. That's also how you define ownership. You say, I could send it away. That means you own it. When I need a private key, where do I get it from? Maybe most of you already went through the process. The standard way currently is that you create a mnemonic seed from 12 or 16 random words. The minimal is 12 words. Every word has a predefined number. And from that number set, a very, very long private key is derived. Here's an example, extra shortened so nobody can use it anyway. And that's a human-readable seed that should be stored, basically, to recover your own private key. A little bit of a warning about safety. Now comes the problems with the private key. I lost my seed. I lost my private key. What can I do? Also, how can I recover my data? How can I recover my assets? And the only thing we can say is, you can't get your seed phrase back ever. You can't get it from the private key back, impossible. The only thing you can do is you create a new account where you have the seed and then transfer all your assets to that new account to make sure you have the seed. Also, where shall I store my seed? I have it written on a paper. Is it safe? Our recommendation is back it up offline, not on a server. Even developers have sometimes their keys on the server that get stolen, so don't do that. And keep them in 2 different locations. So let's imagine your apartment burns out. You don't want to lose access to all your values. When public keys are lost, you don't remember your addresses, no problem. You can just derive new keys. And you may get fancy and say, wow, I create my own sentences. I put whatever words I want, make a nice text from it. No, it's strongly discouraged. Always use a completely random seed. Don't make it easy for hackers. In case you think there's a web page that's faulty, maybe someone trying to scam you, someone convos you, hey, I help you, be very careful. Polkadot put a very nice Wikipedia together, also polkadot.wiki basically. Learn scams, look that up, get an idea where scams are located. Also that's basically the last word about keys is, when you have assets at a location where you don't own the seed phrase and the keys, your assets are at risk. So that's, for example, centralized exchanges. Keep your stuff there as short as possible, minimize the risk. So now we have seen a bunch of things. We have seen that basically blockchains are ready to create the new Internet Web 3, can replace the database efficiently. We have seen distributed networks, ownership, wallet, and digital currencies. Let's think about it for a moment yourself. So what might be missing for mass adoption? What might be missing to make it very big? Or what's your suggestion? Or what you would like to see there? So we came up with the following points and said, okay, energy consumption should be low to reduce transaction costs. We need software upgrades, network upgrades that have to go through without big issues. We want to have communicate with each other. We want to make it big. We need interoperability. And of course, there must be finding a consensus in the blockchain how to upgrade. That's all topics we will cover in the next presentation. So basically 1 presentation for every topic there and much more. So that's how we approach the end of the presentation. The next presentation will be dedicated completely to Polkadot and its ecosystem to see what is there currently available from user perspective. And please mark in your calendar, 26th of October. It's coming up soon. Thank you very much.